This is our second example on waves, and what we have is there's a wave which is being made here, and this wave has an amplitude of 15 centimeters and has a wavelength. As you can see, the wavelength is given to be 40 centimeters from the one maxima to the other maxima, which means that covers one whole wavelength, which is 40 centimeters. The frequency is given to be 8 Hertz, and the question is we have to find the wave number, the time period, the omega, the angular velocity, and what is going to be the equation of the wave. Okay, let's find the wave number, k. So the wave number k is defined as 2 pi divided by lambda. Now we already know lambda, so it's going to be 2 pi divided by 0.4 in SI units, and it will be 5 pi. And what are going to be the units? Well, you see the units will be meter inverse because lambda has unit for meters, so k should have a units meter inverse. Okay, what is time period? We know time period is defined as 1 over frequency. So this is going to be 1 divided by 8, which is 0.125 seconds. How about omega? Well, omega is defined as 2 pi f. We know that pi is given as 3.14 and so on, but we usually use 3.14. Okay. How about omega is going to be 2 pi. You can leave your answer in terms of pi when you solve a problem. Most of the time you can do that, unless the problem does not really require you to specifically find out the exact answer. I mean the answer in terms of numbers, so you can leave your answer in terms of pi. What is frequency? Well, frequency is 8, and that gives us 16 pi radians per second. Okay, this is the angular velocity, and this wave is moving forward in the x direction. So what is going to be the equation of the wave? We know that the equation of the wave is given as y equals a, and if it's moving in the positive x direction, it's kx minus omega t plus phi. Well, we know k, we know omega, we know a. What is phi here? Phi is the initial phase. So we can clearly see the wave does not start at 0. Instead, it starts at a 90-degree phase. You see, this is a 90-degree phase, because if you draw a wave, phase is 0 here. This is pi over 2 or 90 degree. This is pi. We already have discussed this in previous class, and this is 3 pi over 2, and this is 2 pi. So the phase, as the wave starts here, phase is pi over 2. So this is nothing but 0.4, k is 5 pi. Excuse me, I actually made a mistake here. We put a sign, so it's going to be, there should be a sign here. Is going to be a sine k is 5 pi, x minus omega is 16 pi omega t plus pi over 2, and you can actually write this as a sine. You can take pi outside if you want, 5x minus 16t plus pi over 2. Now we know sine of theta plus pi over 2 is cos theta, so this becomes a cos of pi times 5x minus 16t. You see, this thing is telling the wave is moving forward in the x direction. Okay, so these are the basic elements of a wave which is traveling forward.